Hi and hello to everyone. In this video, we are going to see the applications of Laplace transform, particularly how Laplace transform can be used to compute convolution, and how to find a transfer function using Laplace transform, and how to obtain the output for a given input by solving the given system's differential equation. Welcome to the lecture. Let's start with the first problem. The question is, find the convolution between two signals x1 of t and x2 of t. This asterisk symbol is your convolution. Okay, but the question is, do the convolution using Laplace transform. X1 of t is given, x2 of t is given. Okay, we know that the Laplace transform of that convolution of x1 of t and x2 of t is equal to multiplication in Laplace domain or S domain. So if I know the Laplace transform of x1 of t and Laplace transform of x2 of t, I can multiply, thereby I will get the output as y of s. Then after finding the y of s, if I take inverse Laplace transform, I can get y of t. Right? So from time domain, I will be going to Laplace domain. From the Laplace domain, from the answer y of s, by taking inverse Laplace transform, I go back into the time domain. Okay. So instead of doing convolution, what I do? I will do multiplication in S domain or Laplace domain. Okay. So y of s is equal to x1 of s into x2 of s. What is x1 of s? Laplace transform of x1 of t. Okay, so e power minus 3t u of t Laplace transform is 1 by s plus 3. What is the Laplace transform of x2 of t? U of t minus 2. Okay, u of t is 1 by s. U of t minus 2 is time shift t minus 2. So it becomes e power minus 2s divided by s. So this is the Laplace transform of x2 of t. Okay, what is y of s? It's a product of these two, right? Okay, here I am splitting this into two things, right? E power minus 2s into 1 by s into s plus 3 is y1 of s, right? Now we will find out the inverse Laplace transform of y1 of s. So y1 of s is equal to 1 divided by s into s plus 3. I will take partial fraction. We have only the simple poles or simple roots, that is your a by s and b by s plus 3. Okay, so how to compute a and b is given here. 1 by s plus 3, I can take it like a into s plus 3 bs divided by s into s plus 3. The denominator will get cancelled out. So this is the expression. If I want a, what I have to put? S is equal to 0 means b term vanishes, is gone. So a is equal to 1 by 3. Similarly, if I need b, I have to cancel the a. So in place of s, I will put minus 3. So minus 3 plus 3 is 0. 0 into a is 0. So it becomes 1 minus 3b. So b is equal to minus 1 by 3. Now substitute this 1 by 3 and minus 1 by 3 for b value here. Right? A is 1 by 3, b is minus 1 by 3 here. Right? So we got this. So this is your y1 of s. Taking inverse Laplace transform, I will be getting y1 of t. Inverse Laplace transform convert from the s domain or the Laplace domain to the time domain. Okay, so 1 by 3 divided by s is 1 by 3 u of t minus 1 by 3, 1 by s plus 3 is e power minus 3t u of t. So this is your y1 of t. Do you know from the previous slide, y of s is equal to e power minus 2s into y1 of s. Okay, now we got y1 of t. Okay, we have got what is y1 of t, right? So we have exponential term in the what domain? Exponential term in the Laplace domain or S domain or frequency domain. Okay, three names I can use interchangeably, right? Exponential term in the Laplace domain. So there will be a shift in the time domain. So this is the time domain. What is the time domain signal of y1 of s? This is the time domain signal. So exponential term in what domain? E power term. This exponential term is in the frequency domain. So time domain signal will be shifted by minus 2. So it becomes 1 by 3 ut minus 2. Again minus 1 by 3, 3. Okay, beg your pardon. Here I may have missed it out. Here it should be also t minus 2. Okay, again u of t minus 2. So all the time here, okay, all the time variable t will be shifted by t minus 2. Why this is happening? Because of e power minus 2s term. This shift is called time shift, using time shifting property. Okay, in the last video I have explained all the properties, right? Now just we are using this property and we are rewriting u1 of t as u of t, because y1 of s into e power minus 2s is y of s. Okay, so there is an exponential term in what domain? Laplace domain. Okay, but for taking inverse Laplace transform, wherever t is there, I am shifting by the t by this term here minus 2, so t minus 2, t minus 2, t minus 2. So this is the answer. Okay, so we have got the convolution of the two signals in time domain is given x1 of t, x2 of t. What we did, we went into Laplace domain. From the that's the Laplace domain we have solved. We got this. From after getting the Laplace domain, we have taken inverse Laplace transform. Again, we got the time domain. This is the easiest method to solve using Laplace transform. If you don't have, if you are not using Laplace transform, what you will be using? You'll be using, this is your convolution formula, right? Y of t is equal to x1 of tau, x2 of t minus tau d tau. Okay, tau is equal to some value minus infinite to plus infinite. So this is the convolution formula. Okay, this we will be using to obtain the convolution, right? But here using Laplace transform, we have avoided this method. We avoided this method. We went through from time domain to Laplace domain, from the Laplace domain back to time domain. Okay, that's one of the application of Laplace transform. Okay, next thing, we will find the inverse Laplace transform of the given function. Inverse Laplace transform, the question is in the S domain. Our objective is to find x of t. Our objective is to find x. What is x of t? What is x of t? Okay, here again s square plus 5s plus 6, it can be split into s plus 2 into s plus 3. The roots are simple, so it becomes a partial fraction a by s plus 2 plus b by s plus 3. Okay, now find out a and b. Further, what we do? We are using the same method we discussed earlier, using partial fraction. Okay, denominator terms get cancelled out. We get this. To obtain a, we have to cancel the b term. So substituting s is equal to minus 2, b becomes 0. So a into minus 2 plus 3, s is minus 2 this side. So we get a as minus 2. Similarly, to obtain b, what we have to do? We are cancelling b. So if you put s is equal to minus 3, a becomes, this term becomes 0. So b into minus 3 plus 2 equal to minus 3. So minus 3 equal to minus b, b is equal to plus 3. Okay, now substitute this a minus 2, b as 3 here. Now we got this. Now you take inverse Laplace transform. So x of t is equal to minus 2 by s plus 2 is minus 2 e power minus 2t ut plus 3 into e power minus 3t ut. This is the inverse Laplace transform of this. Right? Provided the should be like, to be more specific, it should be causal. Okay, they have to say, if you didn't say, we are generally assuming it is causal, right? We are assuming x of t as causal signal. Assuming x of t as causal, we can write it like this. Why I am saying this is, even I can write this as, the another way of answer writing is, it's minus u of minus t, one form is there, right? That is for non-causal signal. So if it is a causal signal, if it is not given, if it is not given, we are assuming it as causal. Okay, if it is non-causal, we have to write it as u of minus t, here will be minus, here will be plus. Okay, right. Since we are assuming it causal, we can take inverse Laplace transform like this. Next, we will take another problem. We will find out the inverse Laplace transform. So we have to find x of t. X of t is equal to question mark, right? So this is the question. Here the pole is, one pole is simple pole or real pole, k equal to s plus 2. Okay, if you factorize this, s square plus 2s plus 2, you will be getting a complex number. So this is a complex number. So for a complex number, using partial fraction, it should be like bs plus c. Okay, if the roots are complex, the numerator term should be bs plus c. Our objective is to find a and b and c. Note that, right? If it is a simple pole, we will take a. Okay, the simple pole we will take it as A, B, and C. If it is a complex pole, we are going to have the variable like Bs plus Bs plus C. Since we have two poles, we are having B and C. Okay, right? So our objective is to find A, B, and C. Okay, so I'm solving it here. So we cross multiply this term here, this term is coming here, right? So A into S square plus 2S plus 2 plus BS plus C into S plus 1 divided by the entire term. Denominator terms will get cancelled out. Now the important thing is you're multiplying A inside and you're multiplying BS plus C with S plus 1. We got this. Now split the term in terms of coefficients, right? S square coefficients. Take S square outside from these two expressions. From these two. Okay, what becomes A plus B into S square? Next, what about the S term? This is your S term. Here you have another S term. Here you have another S term. From these three terms, if you take S, what happens? 2A plus B plus C. Then we have a constant term. This is your constant term. Okay, so 2A plus C. Right? Now this is equal to 2S plus 1. Right? Now we have to equate the coefficients. What is a coefficient? S square coefficient is A plus B. S coefficient is 2A plus B plus C. Constant coefficient is 2A plus C. Now equate left side coefficient with right side coefficient. Okay. So equating S square coefficient, in the right side we have A plus B for S square. In the left side we don't have S square term. So we put for, instead for left side we don't have, so we put 0 as coefficient, equal to, for the right side S square coefficient is A plus B. So this is the first equation. Now equating S coefficient. This is the S term. What is the coefficient of S? 2A plus B plus C. So 2A plus B plus C. What is the coefficient of S in the left side? It is 2. So 2 equal to 2A, 2 equal to 2A plus B plus C. This is the second equation. Now equating the another term is constant coefficient. In the left side we have constant coefficient as 1. In the right side we have constant. Constant means no S term. That is the meaning, right? So constant coefficient is 2A plus C. So we have three equations, three unknowns. We can solve it. Okay, very simple thing. You substitute or use your calculator and solve. Thereby you will get A as minus 1, B as 1, C as 3. Okay, so if you solve 1, 2, and 3, these three equations, we will get these answers. Okay, now you can substitute A, B, and C value here. A is minus 1, B is 1, C is 3. So we got this. Okay, now our objective is to take inverse Laplace transform of this. Right? So your x of s is this. We have to take inverse Laplace transform. Okay. Now we are moving into very important thing. We know these things already. You have to note down these things already. Like you have to note down this. Okay, we have seen a separate video for how we have derived the Laplace transform of these combinations, right? For cos bt it is s by s square plus b. For e power minus at, what happening? In place of s, I have substituted, because exponential in time domain becomes shift in frequency domain. So s is shifted by s plus a. Right? Just a moment. Okay. In place of s, I have, instead of s, I will be putting s plus a. So sin bt Laplace transform is b by s square plus b square. Okay, so e power minus a sin bt means in place of s, I will be putting s plus a. These things should be clear, right? Now our objective is, once the roots are complex, we have to write this term as any combination of this. Then only we can take inverse Laplace easily. Okay, for that what I am doing is, if you observe, if the roots are complex, you just divide the coefficient next to s by 2. Next to s by 2. What is the coefficient of s? It is 2. If you divide by 2, it is 1. Okay, so it is 1 means what you have to do is, you can split this into, that 1, make it as 1 square. 1 square is 1. Okay, what I am doing is, the coefficient of s I have taken, that is 2, and I will divide it by 2. I will get the answer as 1. I am getting the answer as 1, right? Now make it that 1, that value, square it. Okay, square it. So we have 2 here. So if I put 1 here, I can have the another one here. So 1 plus 1. So this can be written it like this, right? Now if you observe this, this is nothing but s plus 1 whole square. S plus 1 whole square. See, we have to write this as s plus 1 whole square, like this, s plus a whole square, s plus a whole square. For that only I am doing it like this. I will take the s coefficient, I will take the value, that s coefficient, divide it by 2, then I will get the value, that value I will square it here. So this is 1 square. 1 square is 1. Another, so since we have 2 here, another one I am putting here, right? So this term can be said as a square plus b square. If a is s, b is 1, what happens? A plus b whole square is this term. Okay, that green color arrow, green color bracket, again that is said as this term. Okay, s plus 1 whole square. Plus this 1 can be said as 1 square, right? Now if you observe this, it is like, if you compare this, what is the s plus a whole square plus b square. Okay, in the numerator it should be s plus a, then only I can write it like this. In the numerator, if you say it is s plus 3, so how can I write s plus 1 plus 2? Can I write it like this? Yes, you can split this 3 into 1 plus 2. Based on this denominator a, here also I can put a, here a is 1. Okay, so s plus 1 plus 2 divided by s plus 1 whole square plus 1 square. So again you can split this s plus 1 term this separately and the 2 by the denominator separately. Okay, I will split this again, right? Now if you observe this, s plus 1 divided by s plus 1 whole square plus 1 square plus 2 divided by s plus 1 square plus 1 square. Okay, if you look at this, this is equivalent to this term, right? And if you look at this, it is equivalent to this term, right? So it is s plus 1 divided by s plus 1 whole square plus 1 square, right? Here a is 1, this is your a is 1, b is also 1. So it is e power minus t cos t, e power minus t cos t, that is the inverse Laplace transform. Here it is 2 into 1 we can assume, right? So 2 is a constant, so 1 divided by s plus 1 whole square plus 1 square. So here b is, so it's sorry, not this. Okay, now we cannot use this, we can go for this term. Okay, so b is 1, a is also, so b is 1, a is also 1. Okay, so 2 I am taking it outside, so 1 divided by s plus 1 whole square plus 1 square, it can be said as 2 into a is 1 means e power minus 1t sine 1t u of t. Okay, so minus 1 by s plus 1 is minus e power minus t u of t. That is the inverse Laplace transform. Okay, we have to be smart how we are working with this, right? The thing is, once you see a complex pole in the denominator, a complex root in the denominator, try to write it like this. Try to write it like this. For that only I am saying this hint. Take the s coefficient, divide by 2, get that value, then square it. Already if you have a constant, is split into 2 values, that square term plus the new term. Then you can write it like s plus 1 whole square like this. Okay, fine. Now the fourth problem, let's find the transfer function of a given system described by the differential equation. So what is a transfer function? Transfer function is the Laplace transform of output divided by the Laplace transform of input. Laplace transform of output divided by Laplace transform of input. At the condition is at 0 initial condition, 0 initial condition. So this is the transfer function definition. Okay, so in transfer function we are using the time s domain, that is we will take the Laplace transform of the output divided by the Laplace transform of the input at 0 initial condition, right? Here the input is x, output is y. Input and output are related by the differential equation. Okay, and the initial condition should be 0, then only we can find the transfer function. And we know from the differentiation in time domain property, d cube y by dt cube is, if 3 time differential means s cube y of s plus 6 into s square y of s plus 11 into s into y of s plus 6 into y of s is equal to, here it is 3 into d square, 2 times differentiation, so s square into capital X of s, 1 time dx by dt, 7 into s into x of s plus 5 into x of s. Okay, this is very important. In time domain we will be using small y. In Laplace domain or S domain, we will be using capital Y. Similarly, small x we are using here, we are using capital X. Okay, the small things you have to remember, right? For notation, for convenience, we follow these rules. Okay, here we are taking y of s outside in the left side, so it becomes s cube plus 6s square plus 7s plus 6. In the right side, I am taking x of s outside commonly, so it becomes 3s square plus 7s plus 5. Now, what is Laplace transform? What is the transfer function? Output by input. Laplace transform of output by Laplace transform of input at 0 initial condition. Initial condition is 0, so only I can write it like this. Okay, so y of s, x of s bringing to the left side, and this term bringing into the right side in the denominator. This is the transfer function. This is the transfer function. Transfer function. Transfer function generally by the representation, it is represented by h of s. Usually it is given as h of s. Okay, right. Now the next question is, they are given a differential equation which relates the input, output and input is given. They have given the initial condition also, as well as they are asking find the output. Solve the differential equation means they are asking what is the output for the given input. X of t is given. Okay, now, okay, initial condition is given, right? So 2 time differentiation means s square y of s minus s into initial condition minus dy naught by dt, another initial condition. We have seen the property already in the previous lecture 15, Laplace transform property. This d square y by dt square can be written like this. Okay, since the initial condition are given, I cannot ignore these terms because y naught is given, dy naught by dt is also given. If it is 0, initial condition is 0 means I can ignore these terms. Initial condition is not 0, so this is this term is this. Okay, next is 3 dy by dt. Okay, 3 is a constant taken outside. Dy by dt in Laplace transform can be written it like this. S into y of s minus initial condition. Okay, then 2y of t becomes 2y of s. Dx by dt is s into x of s. Okay, right. Now take y of s outside from these terms. Y of s outside from these terms. Okay, this blue color tick mark. If I take y of s outside, what happens? It becomes s square plus 3s plus 2 minus this initial condition and 3 into this term, the other terms. Okay, so s into x of s. Bring all the initial condition to the right side. Okay, so y of s equal to 3s, s square plus 3s plus 2 into these initial conditions plus s into x of s. So in the question, it is given as x of t is given as e power minus t u of t, right? So what is the x of s? X of s is in Laplace domain 1 by s plus 1. 1 by s plus 1. Okay, that's what I substituted here. In place of x of s, I substituted 1 by s plus 1. We got this term. So here the initial condition, what is the initial condition given in the question? If you look at the question, y of 0 is 2. So 2 into s, y of 0 is 2. dy naught by dt is 1. So it is 1. 3 into y naught, 3 into y naught is 2. So 3 into 2 is 6. 1 plus 6 is 7. We got this. Okay. So this is the expression for y of s. My objective, what is the objective? If you want to solve means what do you have to find? We have to find the output. Okay, we have to find the output. Y of t we have to find. Okay, what and all given? The differential equation is given, initial condition is given, input is given, right? Okay, so we have to find y of s. From y of s, we have to take inverse Laplace transform. That way, we will get y of t. So this is my y of s. What I have done for is nothing but just I have taken this. This can be written like this, right? Okay, the left side term has come to the denominator in the right side. Okay, then to solve simple solving, this s plus 1 goes here, and then we can multiply this term plus s divided by the denominator. Then s square plus 3s plus 2 can be split into s plus 1 into s plus 2. So this is s plus 1, s plus 1, s plus 1 whole square. We have this. Now we have to take inverse Laplace transform. If we take inverse Laplace transform, we will be getting y of t. Okay. So to take inverse Laplace transform, the important thing, what are the poles here or what are the roots here? S is equal to minus 1. Because it is square means 2 times we are getting the, this is a repeating roots or repeating poles. For repeating poles, the partial fraction would be a by s plus 1 one time, then b by s plus 1 whole square. If it is repeating s plus 1, then we have to put s plus 1 whole square. Then for s plus 2, it is c by s plus 2. These are as usual. Okay, so solve for a, b, c. This is very important, right? If it is simply no square means we can simply take a by s plus 1. Since we have a square term, a by s plus 1 plus b by s plus 1 whole square. I have write it like this. Now find out a and b. This is a partial fraction. We have this expression. Okay, again we are multiplying s plus 1, s plus 2, then multiplying with a inside, we get this value. Then multiply b inside, then c into s plus 1 whole square, we get this. Then as usual, we will be splitting the s square coefficient, s coefficient and constant. These are the s square terms. Okay, from these two terms, if I take s square, it becomes a plus b into s square. Then we have s terms here. These are the s terms. So 3a plus b plus 2c into s. Then we have constant 2a plus 2b into c. So we got this. Okay, in the left side we have this term. Now equating the coefficients of s square. In the left side the s square coefficient is 2. In the right side s square coefficient is a plus b. So 2 equal to a plus b. Similarly equating the s coefficient. In the left side s coefficient is 10. In the right side s coefficient is, this is the coefficient, right? 3a plus the b plus 2c. Similarly equating the constant on the left and right side, 7 plus 2a plus 2b plus c. Now you solve these three equations. This is the equation 1. Let me say this is the equation 1, equation 2, equation 3. On solving, we will get a as 7, b as minus 1, c as minus 2. Sorry, c as minus 5. Okay. So substitute those values a, b and c here. Okay, a is 7, b is minus 1, c is minus 5. So that's what I have done here. A is 7, b is minus 1, c is 5. Okay. Now we can easily take inverse Laplace transform, because 7 into 1 by s plus 1 is e power minus t u of t. Here it is s plus 1 whole square. So t into e power minus t u of t. So minus 5 into 1 by s plus 2 means 5 into e power minus 2t u of t. So this is the inverse Laplace transform of y of s. So this is the output. This y of t is the output for the input. What is the input given? I think input is, I see it here. Input is e power minus t. This is the input, right? E power minus t u of t. Okay, this is the output for the input u of t. Now we will see very important thing, like what is the step response. The question may be like, what is the step response? If the people are asking what is the step response, what you have to do is, step response, if they are asking, only thing, in place of x of t, we will be using u of t. Okay, so x of s becomes 1 by s, that's all. You have to solve as usual. Okay, if they are asking what is impulse response means, x of t is equal to impulse, delta of t. Then the x of s is for delta of t, the impulse response is 1. Right? So I can make a note here. Note, if input x of t is equal to u of t, then output is called step response. Okay. Similarly, this is the first note. Second note, if the input x of t is delta of t, delta means impulse, output is called impulse response. The question may be like, find the step response, find the impulse response. Okay, here I have given the input as this value, right? So for that we have found the output. If it is for step response, instead of x of t, I will put the input as u of t. If it is impulse response, I will use the input as delta of t. Use the input as delta of t. Okay, this point you have to note it down, right? So these are the things I want to discuss with you in this video lecture. Thanks for listening. Okay, have a happy learning. Do subscribe the channel. Any doubts, please ask in the comment section. In the next video, coming video, we'll be discussing about the Z transforms. Z transforms, we'll be working for the discrete time signals and discrete time systems. Thanks again. Jai Hind.